Hey guys, and welcome to Clear and Campbell's Chemistry Series. Presenting Episode 1, Topic, Principle of Chemistry Part 1. The things we should cover in this episode: the three states of matter and diffusion. The three states of matter include solids, liquids, and gas. Most substances can exist in all three states depending on the temperature. So an example of a substance that exists in the three states is water. So for water, the temperatures would be: solid ice would be below 0 degrees Celsius. Liquid water would be between 0 degrees and 100 degrees Celsius. Gas, steam, would be above 100 degrees Celsius. So the particulate theory of matter, a theory in which discusses the existence of matter itself. So information about this theory would be: all matter is made up of particles. The particles either vibrate, as in solids, or move from place to place, as in liquid and gases. There are forces of attraction and repulsion between the particles. The particles that make up matter can be atoms, molecules, or ions. So continuing, an atom is the smallest particle that cannot be broken down by chemical means. The atom itself is the smallest particle. It's the smallest particle of all particles existing that cannot be broken down. So it cannot be broken down into any simpler or smaller piece. So an atom can be only the smallest particle that exists. A molecule is a particle containing two or more atoms. Atoms can be same or different, meaning that atoms of different elements or the same elements form one molecule. For example, hydrogen gas would be a molecule made of two atoms of the same type, while H2O now, which would be water, is atoms of two types: hydrogen and oxygen. An ion is an atom or group of atoms which either a positive or negative charge. So ions are atoms that are charged. That is, those are atoms that are charged, either positive or negative. So you have to be one or the other in order to be an ion. We can explain the nature of solids, liquids, and gases by looking at how the particles are arranged, how close the particles are to each other, the motion of the particles, the strength of the attractive force between the particles. So the nature of states. So we start off with solids. So the arrangement of the particles are regular pattern, they are fixed shape. The closeness of the particles, very close or touching each other. The motion of the particles, vibrate around a fixed point but do not move from place to place. The attraction forces between the particles are very strong. Now we're at liquids. The arrangement of the particles irregular, no particular pattern. So we learned that liquids take the shape of any container it is placed in. So that's why it has no regular pattern in the arrangement of the particles. It can change depending on what it is placed into. The closeness of the particles, very close or touching each other. Although it's not liquid, it is not generally far apart. So the particles are close but are not close, sometimes touching each other, but because it has less energy than solids, it would slide off of each other. That's what we see as the flowing of water. So the motion, as I said before, will move or slide over each other slowly. The attraction forces between the particles are weaker than in solids, but stronger in gases. So the nature of states continued were at gases. So the arrangement of the particles, irregular pattern. Take the space of any container it's in. Closeness of the particles, far apart. Motion of the particles, move everywhere rapidly. There are almost no attractive forces between the particles. So explain the nature of the states. Solids have a definite shape and volume and cannot be compressed, squashed together. They do not flow like liquids. This is because the strong forces between the particles keep the particles close or touching each other. Liquids have a definite volume, but they do not have a definite shape, and they can flow. For this reason, they can take the shape of any container in which they are placed. The forces of attraction between the particles are not very strong, so the particles have enough energy to slide over each other. Liquids cannot be compressed, squashed easily. This is because the particles are close together. Gases do not have a definite shape or volume. They can spread everywhere. This is because there are hardly any forces of attraction between the particles. Their density is very low compared with that of solids or liquids. They can be compressed because the particles are far apart. So display of particles, as you can see in solid, how close it is together. In liquid, you can see that the particles are sometimes touching each other, but not as close as the solids. So there are a little bit of space between the particles, so which allows movement, and they slide over each other to cause a flow in water. And as you can see in gases, that there is rapid movement, or you can see how far apart they are. So there is space for it to bounce against each other, bounce against other particles that it may encounter. For example, air particles would bounce into the dust. That's what we see in the sunlight through the window, and you see the particles of air bouncing into the dust particles. Yes, that gas has a rapid movement and it's constantly in motion. So you can say that it has a high kinetic energy than of liquid and solid. So the particulate theory continued. 3 tests that proves the particulate theory of matter: diffusion, osmosis, and Brownian motion. So diffusion. So this is a general feedback in which we're discussing in the particulate theory. So in liquid and gases, the particles are in constant random movement. Random movement means that the particles go in any direction. The particles in liquid and gases are constantly changing direction and colliding with each other. The idea that particles are in constant motion is called the kinetic particle theory. So now diffusion. Diffusion is the spreading of one substance through another due to the random movement of particles. So in diffusion, the overall direction of movement is from where the particles are more concentrated to where they are less concentrated, meaning that the particles, so if for example I spray a perfume in a particular corner of the room, this spray now, the particles in this spray will bounce into the air particles in that room until it is evenly distributed or can be smelt across the whole entire room. Diffusion in gases is faster than in liquids. This is because the particles in gases move faster than those in liquids. So examples of diffusion in gas, as I said before, was the perfume is sprayed in a room, and an example of diffusion in liquid would be pouring a coloring at the bottom of a container of water. And as you can see, it would indeed take a longer time for that coloring, for example purple, to spread throughout the whole entire liquid, while the perfume would spread across the room faster because of the constant motion of the particles in gas. So examples of diffusion. So diffusion of potassium manganate 7, also called potassium permanganate, is placed in water. The color of the manganate 7 gradually spreads through the water until there is the same depth of color throughout. This is because both the manganate 7 particles and the water particles in the solution are in constant motion, bumping into and bouncing off each other. So as we can see in this picture, when the manganate is poured at the bottom of the liquid, you see that it is distributed throughout the entire substance until it is evenly distributed here. So example of diffusion in gas now. So hydrogen chloride and ammonia gases are placed along into a tube. So here is the ammonia gas and here is the hydrogen chloride gas. So let's discuss what happens. So the hydrochloric acid gives off hydrogen chloride gas and the aqueous ammonia gives off ammonia gas. So after a few minutes, a white ring can be seen near on the end of the tube. So here's the white ring, or the white cloud. So the ring is near the hydrochloric area. So the hydrogen chloride and the ammonia molecules are in constant motion. They bump into and off air molecules and so move along the tube. So the air molecules inside the tube and the molecules of the ammonia gas and hydrochloride gas would bounce into the air molecules until these two meet and start to react to each other. So the white ring is formed where the hydrogen and ammonia have met and reacted to form a white solid. The ring is near the hydrochloric acid end because hydrogen chloride is a heavier molecule than an ammonia molecule. Heavier molecules move more slower than light ones. So ammonia, which has a lighter molecules, will move faster because of its weight. So since it's lighter, it will move faster, so it would bounce off the air molecules faster, so it would reach to the hydrogen chloride gas end quicker than the hydrogen chloride molecules itself. So that's why when they meet and form the white ring, it will be found closer to the hydrogen chloride gas end. So guys, this is the end of the video. Please like the video if you enjoyed it and share it with a friend who really needs this video. And don't forget to subscribe for more videos like this. Bye.